Hey guys, welcome to the Physics Connection. This is Salem, and in today's video we're gonna do something really cool. We're gonna talk about physics in your everyday life. The first thing that we're gonna talk about is a refrigerator. How does a refrigerator work? Think about how weird this situation is. If I gave you a glass of water, maybe 100 years ago or maybe 200 years ago, and I told you, here, make it cool. What are you gonna do? How do you make something cool? Are you just gonna blow on it? How do things actually become cool? In order to understand how to make something cool, you first need to understand what temperature is and what heat is. So if I take a gas, say a hot gas, and I look inside, what am I gonna see? If I have a very good microscope, I'm gonna see a bunch of molecules or atoms going around very quickly, bumping into each other. If it's a gas, the atoms are gonna be like this. They're gonna be far away from each other. Every once in a while they hit each other, but they're not gonna be condensed close together. But in any case, for a hot gas, these molecules are gonna be moving really fast. Sometimes they're gonna hit each other and they're gonna hit the walls really fast. So in order to get a cold gas, you need to make these molecules move slowly. And the way that you need to make them move slowly is you need to let them lose their energy to something else. So let's say I take this gas, and it's over here in this compressed region, and I suddenly let it expand very quickly. I don't give it enough time to lose its energy or to gain back energy from the environment. I just let it expand very quickly. Let's think about what happened. The gas started here, one of the molecules are in here, and because the gas is in a small region and it was closed in by the walls and had a high relative pressure compared to the outside, as soon as you let the walls go, these molecules are in there and they want to start moving out of that region. So let's take one of these molecules, it's moving, and then it suddenly hits one of the air molecules that was there already. It hits that air molecule and the air molecule flies in some direction, and this gas molecule loses some of its energy. So that's how you can let the gas lose some of its energy, by expanding it really fast. When it expands really fast, it loses that energy to the surrounding environment by collisions. It just pushes the environment away and cools down. Fact number 2 that you need to understand before you can understand a refrigerator is that when you compress a gas, it will boil at a higher temperature. So take water, for example. It usually boils at 100 degrees Celsius. Below 100 degrees, it's a liquid. Above 100 degrees, it's a gas. But you can take maybe a water gas, which is at a pressure of, say, 200 Celsius, but you can take that 200 Celsius gas and compress it, and when it's compressed, it becomes a solid, even though its temperature is 200 degrees and not 100. So again, to understand how that happens, let's look inside and see what the molecules are doing. So the molecules in the gas, they're like this, they're far away, they're moving around randomly. For a liquid, they have to be close together. They spend more time next to each other. So they're still free to move however they want, but they spend more time next to each other. So if I take a gas and I force it to compress, now the molecules are spending more time together and they turn into a liquid. So now we're ready to understand how a refrigerator works. In the refrigerator, the most important actor in cooling is something called a refrigerant. And this is something with a very low boiling temperature. So it could be, say, minus 27 degrees like ammonia or something like that. So you have this refrigerant which boils at a very low temperature. So it starts inside the refrigerator in some pipe, and inside the refrigerator maybe the temperature is, say, 1 Celsius, and we're trying to cool it down to 0 Celsius. So at this 1 Celsius, the refrigerant is a gas because it's much higher than its boiling temperature. Now, what we do is we take this gas and we compress it quickly. When we compress it quickly, remember what we just said, it turns into a very hot gas. Let's say it started at 1 degree Celsius and all of a sudden now it's 200 degrees Celsius. Now at this 200 degrees Celsius, even though it's compressed, it's still a gas because it's a very high temperature. But what we do is we take this gas, before we let it lose its temperature to the inside of the refrigerator, we send it outside the refrigerator. Now outside the refrigerator, the temperature is, let's say, 20 Celsius, and if we let this gas cool from 200 Celsius, the refrigerant cooled from 200 Celsius to 20 Celsius, it turns into a liquid. Even though 20 Celsius is much higher than the boiling temperature of normal boiling temperature of the refrigerant, because it's very compressed, it still turns into a liquid. So we send the liquid back into the refrigerator at the 20 Celsius, but now we let it expand very quickly. And remember, when it expands very quickly, it cools down and it turns into a temperature of, let's say, -40. Now -40 is lower than the boiling temperature, so it's a liquid. Now this liquid inside the refrigerator, which is 1 degree Celsius, it starts to heat up and take energy from the refrigerator, and it goes from -40 to -27 and then boils and turns into a gas. And then we repeat the cycle and take it outside back again. And that's how you can keep taking energy away from the refrigerator and letting it radiate outside. So this is how refrigerators work, and this is also how air conditioners work. Next time we're going to talk about how TV and liquid crystal displays work. So thank you for watching and stay tuned.